Welcome to Developer Skill Sprint. My name is Pawel Glowacki. I'm working for Embarcadero as EMEA Technical Lead for Developer Tools. And today we are going to start the new series of 2016 Developer Skill Sprints from 3D data visualization. How skill sprints works? Skill sprints are short, typically around 20 minutes long recordings where we demonstrate useful programming techniques, just focusing on one area. So programs that I'm going to develop today can be implemented in either Object Pascal or C++, and from the same source code can be natively compiled to Windows, Mac OS X, Android and iOS. Today I'm going to start from explanation of some of the key FireMonkey 3D programming concepts, and then I'm going to move to demos. I'm going to start from a simple demo that I'm going to build from scratch, explaining some useful techniques for building 3D applications, and then I'm going to move to the complete end-to-end demo called Molecule Hero that can be downloaded from Google Play Store, and also the source code of this demo is available from GitHub with no restrictions. Its full source code is completely free, so you can download, build and play with some more complex examples of 3D FireMonkey code. Okay, so what is so unique about the FireMonkey 3D? The key thing is that you create your application once and you can natively compile for all supported platforms. In case of 3D programming, we use regular 3D APIs that are provided by operating systems like Windows, like Mac, iOS and Android. But FireMonkey provides a nice abstraction, so you implement your application once in either C++ or Object Pascal code, and FireMonkey takes care of mapping this abstract code to actual API on different frameworks. So if you compile your Delphi or C++ Builder application on Windows, you are actually using DirectX. If you compile the very same application on Mac, you are using OpenGL, which is completely different set of 3D APIs. And for mobile platforms, we are using a subset of OpenGL, OpenGL ES. So that's a very unique architecture. And there is also full object orientation here. So FireMonkey provides an abstract class tContext3D that provides common methods that you can call from your application code. Typically you don't need to call these methods directly because you can use high-level components that will make calls to these methods and properties, and then depending on which platform you compile your application, these calls will be translated to actual specific 3D APIs provided by classes for different supported platforms. So this is very useful because you don't need to learn multiple different object models. You just need to use high-level components or directly call methods on tContext3D, and you can make a fully functional 3D application. So important thing to understand is the Objects 3D hierarchy. So FireMonkey in both Object Pascal and C++ Builder provide a set of components that makes possible to create fully functional 3D applications without spending a lot of time on coding. So all objects in FireMonkey derive from FMX object, which is a direct descendant of a T component, which is a base class of all components in Delphi and C++ Builder, not only FireMonkey but also VCL. But TFMX object is a base class that provides basic functionality like parenting that is typical for FireMonkey applications, not only 3D but also traditional 2D. And then we go into the tControl 3D class that derives from TFMX object, and this is a base class that provides a basic functionality specific to a 3D application. So this class introduces properties like position in a 3D space, like scaling, rotation, also user events, so you can click on objects, you can double click on objects, and then there are some direct descendants from T-Control 3D, like T-Grid 3D or T-Stroke Cube. So these are quite lightweight classes that directly calls into methods of Context 3D, and specifically Context 3D Helper, to draw lines in 3D space. And then going further in the hierarchy, we have a T-shape 3D. So this class introduced support for materials. So in FireMonkey 3D architecture, there is separate components that encapsulate different materials, and so T-shape 3D introduces a material source property, and there are certain classes like T-text 3D, T-path 3D that derives from T-shape 3D. Going further in the hierarchy, we have T-custom mesh. So this is a class that introduces mesh data. Mesh data is an encapsulation of typical for 3D applications vertex buffers and index buffers, and then we have different classes that provides different 3D primitives like sphere, like cylinder, like plane, and so on. So these are the classes that we use to visualize our 3D worlds, but then we have certain additional components that are necessary to build a fully functional application. So things like light that provides lighting, so our objects that we put into the 3D space have the directional point or spotlights. We also have camera in FireMonkey 3D. We have a built-in camera, so using of camera object is optional, but it is useful in more complex applications to use camera directly. Another very useful component is a T-dummy. T-dummy is a generic 3D container. It does not have any visual representation, but it is used to group objects, so you can manipulate them all together. There is also a descendant of a T-dummy called T-model 3D. So this is a special component that let you import 3D files created by some external tools, so you can directly in your FireMonkey application visualize quite complex 3D entities that maybe are too difficult to model using primitive shapes. Also, there is another object called T-proxy object. This object is used when you have a number of identical objects, like you want to have a lot of spheres, for example, or a lot of cubes. So instead of having the mesh data, so the vertex buffers and index buffers for each object, you can use proxy objects so you don't duplicate these resources. Okay, so that's theory, and now let's go into the demonstration. So I'm going to actually jump into the RAD Studio, and first I'm going to create a new simple multi-device application. So when you create a multi-device applications in either Delphi or C++ Builder, you have a certain templates. There is one of the templates is a 3D application. If you select a 3D application, you will have the main form of your application will be a 3D derived from a T form 3D. However, I would not use this approach to create 3D applications, because the form 3D as compared to the regular 2D forms does not provide enough functionality, for example, for supporting multi-touch on mobile applications. So it is much better, I'm going to close this application without saving it, to start from a regular 2D application, for example, blank application, and on top of this application, on this form, we can use a Viewport component that provides a view into a 3D space. It's typically common to align this viewport to client area so it occupies the whole screen. We can change the color of this viewport from white to black. And what I'm going to do right now, I'm going to build a simple visualization of Earth and Mars rotating in a deep space, and also demonstrating some of the key concepts of building applications in 3D. So I'm going to start with adding a T-dummy component. So T-dummy component is a useful component for grouping other objects. So it does not, when I run the application, let me save this application as a simple 3D demo, new folder, simple 3D. So I'm going to save this application. So if I, okay, this is a simple 3D. So if I run this application, it will just be black. So the dummy does not provide any visual representation, but it's useful for grouping other components. So here in a 3D scene, we have components, and on 3D shapes, we have different components that we can put here. So if I want to visualize Mars and Earth, I'm going to add two spheres. In FireMonkey and also in FireMonkey 3D, it's very important to understand which component contains other components. So I want to make sure that my both spheres are contained directly by a dummy, and I'm going to change the name of the first component to sphere Earth and the second component to sphere Mars. Okay, and then I'm going to actually, because right now these components, they have a position 0, 0, 0, and so they just are on the very same spot. So I want to actually move them a little bit away. So I'm going to change the X property of my Earth to be something like -1, or maybe -2, or -1 will be fine. -1, and the Earth, the Mars, will be +1. So in FireMonkey 3D, we have three axes. So the X direction points to the right, the Y axis points to the bottom, and Z axis points into the screen. So now, right now, I have two spheres. So I want to actually make them look like Mars and Earth. So the next step is actually to add a material. So in the materials tab, the object in the tool palette, we can add different types of materials. So they represent different models of shading. I could actually use a T-color material source just to give any shape a color. I could use a light material source to give it lighting, like for example Guru lighting, or I can use texture material source if I want to apply a certain texture to the object. So I have two objects. One is for Earth, so I'm going to take this first texture material source and call it texture material source Earth, and I can now load into the texture some predefined. I have here in pictures, I have downloaded earlier from internet an open source texture of Earth. So now I have this texture loaded into the component. If I click on my sphere Earth, there is a property called material source I can use to assign to this component. And now I need to have another texture component for Mars this time. So I'm going to do it like this, Mars, and I'm going to load another texture, this time with the image of Mars. Okay, so this is my Mars. So I have now two textures. So also need to set the material source property to be Mars. Okay, so we have now two spheres, and like I said, the dummy is a useful container. I can use dummy to, for example, change the scale so my image looks bigger, so I can, for example, make it 3 times bigger in the X direction, 3 times bigger in the Y direction, and 3 times bigger in the Z direction. Also, notice that when I change the property of the dummy, all contained objects actually inherit this property. I can change also things like, for example, oh, that's maybe not a good move. I want to change the rotation angle, like for example 45. So just by adding different objects of the 3D scene to the dummy, I have just one place to manipulate the whole scene. Okay, so that's good. So I have two nice objects, but typically I would like to see some rotation. Let me add a rotation components, actually animation. So I need to have float animation. So I double click on float animation, and this float animation has been added to the sphere earth component. So if I open the property name, I see all the properties of the sphere that are of type float. In this case, I'm interested in animating rotation angle Y property. I want to make it loop, and the duration will be maybe not so fast, but maybe one second. I want to make sure that this is enabled, and also start value and stop value, I want to go from 0 to minus 360, so my earth is actually rotating in a correct direction. And let's see what we have here right now. Okay, so this is my earth is now rotating. So this is actually, I have not written any line of code, so this is exactly the same steps for Object Pascal and for C++ Builder, and I have a nice visualization of a rotating earth. What is also very interesting is that this is interactive. So if user clicks on different elements, he can actually interact with the scene. So what I'm going to do is I'm going to implement the onclick event on sphere earth. So when the user clicks, then the earth will come closer, and when he clicks again, it will go further away from the viewer. So first I'm going to change the location of the sphere earth to be somewhere closer to us. So the Z direction, the Z coordinate goes into the screen. So if I want to make it to look closer or bigger, it has to have some negative value. I'm going to add it negative value -3, and now our earth is quite close. If I make it 3, it is quite far away. So I'm going to make it -3, and I can now double click on add the on click event to sphere, and I'm going to change its location. So if my sphere earth position Z is actually smaller than 0, then I'm going to move it to the sphere 0 equals 3, and otherwise I'm going to make it to move it closer. Okay, sphere earth -3. So that's a little bit of code. The code in C++ will be very similar. And now if I run the application, I have a 3D application that is also interactive. So these are some key techniques for building 3D user interfaces. And now let's have a look on something more complex. So I'm going to move to the molecule hero that I have created back in started to work on it back in the XE2, Delphi XE2 time frame when the FireMonkey was introduced, and now it is implemented in the latest RAD Studio 10 Seattle. So I'm using here components like multi-view. So and also this multi-view is used as a menu for displaying different predefined chemical molecules that are actually hard-coded inside of the application. Notice here I'm also using, this is one big viewport, but I want to add certain functionality. So you can use just a regular T layout component to put traditional 2D components on the 3D screen without really taking away the space of the screen. So if you would use a toolbar, then your viewport will be smaller. You can use a layout, and then you can put things like a T label or a T speed button on the form. Let's have a look how this application works, and then we can have a look at the source code. So this is probably the most important chemical molecule in the life of a developer, caffeine. So that's something that makes us code efficiently. So I can visualize, you notice that this is again, I'm using mouse on Windows, but on Android, on iOS, I would use just a touch. And then I have a different modes of visualization. I can visualize atoms and bonds. I can just visualize atoms without bonds, or I can just visualize bonds alone. There is also functionality here to make it closer or further away. And then I can change one of the predefined molecules that are built into this application. So that's a demo application, so there is no possibility to actually visualize other molecules, but that will be relatively easy to achieve, and that's my goal for the 2016, to add a functionality to this application to visualize arbitrary 3D molecules. So here I'm using a PDB format for the protein data bank. That is actually standard format for exchanging chemical molecule information. Also here I have another form. So this is for 3D. So this is a molecule hero. So that's a nice, I hope nice artwork that is necessary for this application to be accepted on one of the Play stores. Okay, let's get out of this application. Let's have a look how this application is structured. So these so there are two main. So we have one main viewport and one dummy component. Here is a camera component. So the camera component is actually, you can see there is a camera and light, so you need to have so I have light exactly in the same place as camera. And also the viewport main has a property called camera, so I can connect camera to the viewport. And also there is a property use design camera set to false, so the viewport does not use the camera that is built into the FireMonkey framework, but the one that is placed on the form. Okay, so we have also something called import PDB. So that's a generic code to actually take a PDB file and read it parse it and read it into the a certain structure. So here I'm going to actually, there is a molecule class here. So this class represents a chemical molecule. So there is a record that represents an atom with a position in a 3D space and the type of the atom, and also the bond, which is just a connection between two atoms, and the molecule itself contains the atoms, which is a generic list of atoms, and bonds, which is a generic list of bonds. So that's this molecule, this this class is then used in the main form of application. So here on the on a list view, I have a list view, and there is an on-item click event that is actually used to load a new molecule into the viewport. So let's have a look how this method is implemented. So I have this DM main, so this is my main data module, and I'm going to load a molecule into the dummy, and this is specified by the index. Let's have a look how this method is implemented. So I'm creating just an empty molecule, and then I need to get a molecule by index. So this is where I'm going to get the molecule from strings, which is a PDB file. And then in the next step, I actually need to load the molecule into the control 3D. So this is a special method called load molecule, and this is what I'm doing here. So basically, it could be loaded into the arbitrary control 3D, which is an ancestor of a T-dummy component. So first of all, I want to delete all the children. So if there is an existing atom already loaded into the dummy, I want to get rid of it. And then I'm going to actually go through the atom. So through the collection of atoms in my molecule, and I'm dynamically creating a sphere component in code. So I need to provide also the parent, which is a control, and remember that I have to assign also the material to the sphere. So I have another special component here. This is my mats materials, and this is the class that contains a list of material sources, and there is I'm building a light material source in a lazy fashion. So the very first moment you specify the atomic number of an atom, so you have different colors, and these colors are actually taken from a certain, let me show you, from a certain website that I have got some PDB files. So there I have these materials, and I can go to the my material sources and molecule hero utils, and these are my utils, and depending on a type of the atom, there is a code for the color. So for every atom in the Mendeleev table, there is a different color, so my atoms does not have the same color. So in this way I can create I can assign materials to my spheres. I specify also the scale, so atoms have different sizes, and I need to also specify the position in a 3D space. So after I'm done with adding atoms, I need to add cylinders, which represents bonds. So I need to read the bonds collection, and then there is some mathematics here involved to make sure that that cylinder is properly positioned in the 3D space, and its ends are actually in the same locations as atoms that it connects to. So this application is also can be compiled and is compiled for Android, for iOS, and also for macOS. And this is really the beauty of this model, FireMonkey 3D models, that you can create quite complex code, and from very same source code you are able to natively compile to different platforms. Okay, let me jump back to the presentation. So I hope that I'm still on the right slide. So let me jump very quickly to the last slides. So there are a number of different resources that you can use to learn more about FireMonkey 3D programming, and also the source code for the molecule hero application is provided. So this is on a GitHub. You can actually get the source code of this application, and you can analyze it to see how you can structure more complex applications. So this application is also available on a Google Play Store. So there are different screenshots from this application, so you can actually see how this application behaves on a actual device. And on documentation for FireMonkey 3D is available online on docwiki.embarcadero.com. So there are explanation of different 3D objects and also different tutorials that you can use to be more up to date and up and running with developing 3D applications. So we are getting to the end of this very first episode of Developer Skill Sprints. So the next episode will be on saving and retrieving settings on iOS and Android, and that will be exactly in 1 week from now. So every Tuesday we have a Delphi version of a skill sprint, and every Thursday, 2 days later, we have a C++ skill sprint on the very same topic. So there is these skill sprints are actually in 3 different time zones, so this is pre-recorded. So if you have any questions, the recording will now stop and will be live for answering your questions. Thank you very much, and I hope that you will enjoy the whole skill sprint series. Thank you very much.
Okay, David, I here. Let me bring Pawel in.
Yes, I'm here. Hi, David. Hi, everybody. I'm super happy to be the first person to start this 2016 series of skill sprints. So yeah, it's very great to be back on track for doing some more coding in 2016. Happy New Year to all developers online.
Excellent. Let's see. Sorry for recovering from cold. I think there was a question about doing data visualization related to a data set. There's no specific binding of a data set, let's say, to a 3D object, but you can do that in code. Is that right, Pawel?
Yeah, yes, correct. So basically what I was trying to focus on in this skill sprint was to show some basic techniques, how you build 3D visualizations, and then what kind of visualization, what kind of components you use. It's really up to a specific application. So you might be, for example, like I have been using spheres in a 3D space to visualize atoms, but you could, for example, visualize some data coming from a database table also in a 3D space. So you just need to, you can actually do this in code, or there are examples of using visual live bindings for binding different, for example, values from either from a data set or from just arbitrary data structure, and bind them, for example, to the radius of the sphere, or maybe the height of the cube, and so on. So that's we don't have anything built in, because I think that would be limiting the possibilities. So it's really up to the developer to decide what he wants to visualize, and which data should be bound to which aspects of a 3D model.
There's a question here about using T-Model 3D, one of the objects. Can you work with DirectX files with meshes or CubeMap textures?
Yeah, I have seen this question in the question pane. I'm not exactly sure. I'm not very familiar with DDS files. So we do not provide support for the DDS files. What we do provide is support for standards like DAE, ASE. So these are the standard file formats that can be exported from the 3D modeling environments to export 3D information, and then you can load this information into a model 3D using a load from file function. So that's something, there are some examples of doing this. but we don't have as direct support for DDS files. Maybe that's something that could be implemented, but that would require really looking and researching more about what are the possibilities.
Yeah, I think we had a sample for, it wasn't a direct import using T-Model 3D, but I think we had a sample for loading some other 3D model format, didn't we?
Yeah, we did have actually I think there was back in the XE2 days there was an example of loading the 3DS files, and I think as long as we have programmatic access to meshes, we can work with meshes directly. So actually inspecting the source code of a T-cube, 3D, T-plane, T-sphere is very interesting because it is not very complex code, and it shows how you can work directly with the vertex buffer and the index buffer to create a 3D structure. So typically those classes are quite lightweight on top of the functionality that is already provided. So just by analyzing it, you can possibly work directly with meshes. So if you can programmatically access information about the mesh data that you want to visualize, it should not be a very big deal to actually work programmatically directly with a mesh data and build arbitrary 3D objects.
Then there was a question about managing the type of line, color, etc. in 3D.
Let me check the question. Actually, if you look back into the presentation, there was this hierarchy of the 3D objects, and then there are actually two levels of complexity. So there are some really lightweight components like T-stroke cube or T-grid 3D, and they do not really work with mesh data. They just directly draw within a 3D space lines using a certain color, and this is the functionality provided by directly from actually from a T-context 3D, and there is a context 3D helper class that adds some functionality, like for example drawing line, drawing cube in 3D, and the context 3D directly gives you functionality to draw lines in 3D space, just specifying the color. So you can really directly calling into the context 3D, you can play with it. There is a sample that comes with the installation of RAD Studio called low-level 3D, and then it actually shows how you can build how you can directly call into these low-level APIs. I hope that it answers the question.
Okay, and then there was a question about can the material be something like environment map to provide reflections like metal objects or water? I mean, the material can be any bitmap, right?
Yeah. So basically, we are getting closer to the thing related to shaders. Yeah, back in the XE2 time frame, we had this demo of a fire monkey character that was actually was using different bitmaps for providing different materials like what is specular lighting, what is the diffuse lighting. So you can create some complex and really great looking visualization, but we don't have really abstractions that are out of the box that you could use. So that would require some coding, but this is definitely doable.
And that's coding if it's not just a simple bitmap that you're laying over, right?
Yeah, because what we are using here is just texture that we are applying to the. So if you are using texture material source component, you are specifying a bitmap that you are applying to a different 3D object. And then if you look into the source code, in the vertex buffer, to specify things like location in the 3D space, but also you need to specify the normal vector, but also you specify a coordinate in the associated texture through a text chord property of the vertex buffer, and that's what is provided by the FireMonkey model. You cannot really assign multiple vertex buffer, but if you look closer into the source code of FireMonkey, you can see examples of effects components that are using shaders directly that are embedded into the source code. So probably that would be the starting point to implement more complex effects in a 3D space. But again, this is not something that we provide out of the box. I'm actually working on we have another skill sprint in 2 days in a C++ version of this skill sprint. So I'm not going to repeat the very same source code. So hopefully it's going to be also interesting for Delphi developers to see some more of a 3D programming in FireMonkey. So yeah, everybody that is right now online is encouraged to get back in 2 days for maybe more informative and more information about the FireMonkey 3D.
Sorry about that. One of my machines died over here. Pawel, you were saying? Sorry, I had to change headsets.
Yeah, there was a question, can we have more 3D demos like, please, maybe something that builds a ping-pong-like game? Yeah, I think that's a good idea to create, to focus a little bit more on 3D. I was, one day, I was talking with Marco Cantu, and we were both agreeing that the 3D it would be great to give some more love to 3D programming in Delphi, and I believe there is plenty of space to make it more functional. But it's also, yeah, question to all developers online and other developers. Yeah, this is all driven by your request. So if you feel there is something obviously missing in FireMonkey, we at Embarcadero, we are always listening to your feedback, and please feel free to send us email, send an email to me, to David, to Jim, to Marco, and we will give this feedback to the R&D team, and we'll see what we are going to have in future versions of RAD Studio.
What is the difference between the T-ellipse 3D and the T-cylinder? Are they the same?
Yeah, I was trying to answer some of the questions already in the question pane. Actually, they are not the same. The main difference is actually depicted on this slide with the object 3D hierarchy. So the T-cylinder component has its own mesh data, so it has its own vertices and its own indices. The T-ellipse 3D is actually directly derived from T-control 3D, actually through the T-extruded shape 3D, so it does not have a buffer. It is rendered. It's more lightweight. So they are definitely not the same components.
And then can the T-model 3D be used to visualize ESRI 3D shape files?
Yes, I was in the meantime looking up this ESRI file format. So the answer is not, actually not directly. So the only 3 file formats that a T-model 3D supports is OBJ, ASE, and DAE. So in order, you need to convert from other formats to one of these 3 formats in order to be able to load into the model 3D like arbitrary geometry.
What kind of texture maps does FireMonkey support? Does it support bump maps or just normal maps?
Actually, the only textures that FireMonkey supports out of the box is just a plain bitmaps. So obviously in a 3D programming there are more complex bitmap textures that you can actually use. So we do not use, or there is no direct support for using other types of textures rather than just plain bitmaps. So we don't have a bump or normal maps. So it would be nice to have. That's something that would be very useful and interesting. Probably we could have even more power, but it's not supported out of the box.
For getting back to the models, 3D models, I've used SketchUp Pro, the trial edition, to convert models into the ones that we support. So if you download the free trial, it gives you like 8 hours, and all you need to do is load a model and export it to one of the formats that we support for SketchUp Pro, and you'll use about 10 seconds or 20 seconds of your free trial time, or maybe a minute. So 8 hours, you could be converting a lot of 3D models to use them with T-Model 3D. Sorry, I wanted to mention that. Go ahead, Jim.
That's a good tip. I've used SketchUp Pro as well. So it used to be completely free, but anyway. So here's a question in there. Someone else had a related question. It says, can you add a texture to a Viewport 3Ds, like for example, put a star field in the background?
Not directly. Actually, going back to what David said, there is also a nice tool called Blender, which is completely free, open source for 3D modeling, and you could actually use this to convert between formats. And going back to the question, you cannot really directly add textures to a Viewport 3D because it's a different concept. Viewport 3D is more like a component that encapsulates the graphics context. It's not something that can, but you can do different approaches. You can actually use, for example, a T-plane component and use a texture material to assign for if you want to achieve a star field. Back in I believe Code Rage 4 or 7, I have been demonstrating a 3D application that was using model 3D components to simulate a star field. So the answer is not. You cannot add texture directly to a Viewport 3D, but if you want to achieve effects like star field, you can do it in different ways.
Yeah, Jens suggested the term skybox. You just put 12 polygons out in the background that are far away, and then just have your texture on it. Can you have several 3D viewports on a form at once?
Yes, you can. So you can. It's like the very first thing that I did on the first demo was to put a viewport in. It was not aligned to the whole form. I had to align it to the whole view. So you could potentially have multiple viewports, for example, to visualize the same 3D model from different directions. So the answer is yes, you can. It's actually sometimes it can be tricky, or at least it was in the previous versions of RAD Studio. Working, combining 3D viewports with 2D forms, but nowadays with RAD Studio 10 it seems that it works flawlessly.
So actually I want to follow up on that question just to make sure I understand. So you're saying you can have two viewports that are both doing the same 3D model from a different angle?
Yeah, actually the thing is that they would be completely different. So it's up to you as a programmer to provide the visualization of seemingly the same model, but looking at the that would be a different shapes or different 3D objects on each viewport. But yeah, it's just up to you as a programmer to show them from different angles to give the end user the experience that is the same model viewed from different angles or different directions.
Okay, so you'd have two viewports, and you could put the same model on both of them and set them to different angles if you wanted to, but
yeah. So for example, let's say we would have a chemical molecule, but then I would need to load in two dummy components, two different sets of spheres and cylinders, but just to rotate them differently. So you would have an feeling that is just the same thing viewed from different angles, but they would be independent from the programmatic perspective.
So my thought was, if you're using a device like Google Cardboard to provide a stereoscopic 3D if you would, so you could just put two viewports down. You'd have to replicate the model across the two viewports.
Yeah. So that would be two separate viewports with their separate sets of 3D objects, but it's up to you what you display it at any given moment.
Okay. So can you achieve something like glossy or reflection or other effects with FireMonkey?
Yes, you can actually. There are three different materials that you can use in any for adding materials to your objects. So you can use a color material source, so then you just assign just a plain color. You can use texture material source, which I demonstrated when you can assign a bitmap, but you have also something called light material source, when you can specify different types of colors for ambient light, for diffuse light, for emissive light, and for specular light, and then you can actually achieve things like glossy, shining. So that's possible, and yeah, the answer is yes, you can do it.
Okay.
Actually, the light material source is implementing the Guru shading model, and that's yeah, you can specify which color should be this glossy specular thing, you know.
Can you set the frames per second or video memory utilization, or determine the frames per second or video memory utilization from FireMonkey?
Actually, it's not that you can set the frames per second, but actually the question originally was if you can find out what is the current frames per second, and that's actually the property of a context 3D class. And so you can read this property to find out what is your current frames per second. Yeah. You actually, it's especially when you are doing mobile development, I would actually use some tools provided by the, for example, Xcode or Android Studio, and they have their own set of diagnostic tools when you can actually see, regardless of a tool which is used to create a graphics application, to find out what is actual ratio. So yes, you can definitely.
Okay. Lots of comments about great webinar, lots of good information. Thank you.
I put a couple of links into the doc wiki for the light material source and specular, and there's a property called shininess if you want to change the shining level. So those are in the Q&A log. Sorry, go ahead, Jim.
Thank you. Here, Jens is asking, I'm a bit confused when you say FireMonkey only supports plain bitmaps and no bump maps or whatever. It says you did something similar in XE2, which looks very impressive, normal maps, everything, and he has a link here.
Yeah, this is a link to the original FireMonkey Datox demo. So that was a demo that was created as a proof of concept at the time when FireMonkey 3D was just being introduced to Delphi. So at that time it was even before the first version was introduced. So yes, it's correct. This demo with a FireMonkey character and a space station character, it used to be a demo that was part of the demos that were installed with RAD Studio, was demonstrating using more complex lighting models where you can combine different bitmaps. So that's something that is not really, the object model of FireMonkey 3D does not support this. I believe that will be a good direction for product management to actually follow and to add this. So it was more like a proof of concept, and it really worked great. So yes, what I can say more. That's something that potentially should be possible to achieve even today, but we do not have this available out of the box, so it's not something that you can do in a few lines of code. You would need to actually go dig deeper into the FireMonkey code to achieve these effects.
Okay, excellent. Well, great. This was a lot of good information here. This 3D is something I have not experimented with much, so I certainly learned a lot, and hopefully everyone else did as well. FireMonkey certainly is very powerful, and that makes it so easy to do both 2D and 3D and then make it cross-platform with the cross-platform compiler. So great information here. Thank you.
Yeah, I think that's the cool thing about the FireMonkey and the Delphi in general is that making difficult things easy. So using high-level components to encapsulate some really complex mathematics is really something where FireMonkey 3D shines. So normally to build this rotating Earth in some other tools, you would probably need to do a lot of 3D mathematics and probably write hundreds of lines of codes. And here we can do some really spectacular things without writing any single line of code, just putting components and compile from the same project to different platforms is something extraordinary.
Yep, excellent. Are you going to put the code for your little Earth Mars thing available for download?
Yes, definitely. That's my on my to-do list for tomorrow. So I'm going to put on the community.embarcadero.com on my blog the code. Actually, the code is not very long, so it's just 2 lines of code, and I'm going to make it better. So instead of just jumping from -3 to +3, I'm going to use an animation so the Earth will actually go from one place and not just jump from one place to another. So that's something I'm also going to provide in C++. So for those that want to learn more, please feel invited for the C++ version of this webinar in 2 days, same place online. So I hope to have some more demos. So it's not going to be exactly the same webinar. It's going to be this webinar extended.
Oh, excellent. Very cool. Looking forward to that one.